We spend so much time talking about code, frameworks, and APIs, but what about what's underneath all of that? Behind every single app, every purchase you make, every video you stream, there's this deeper system. It doesn't just hold data, it literally organizes our reality. This is the story of that system, the database. So let's just start with that question. What is this invisible architecture, really? Because this isn't just a story about, storing files. It's a story about structure and power and even control. It's about how we, as a civilization, decided to organize information and how those choices ended up shaping, pretty much everything.
And that's the crazy part, right? It is arguably the most important, the most foundational system in all of computer science, and yet it's the one we think about the least. So today, we're going to change that. We are pulling back the curtain on the untold story of the database.
Okay, so our story has to start way, way back. We're talking about a time when data wasn't some abstract digital thing. No, it was physical. You could hold it. We're heading back to the mechanical age, to the very first attempts to get a handle on information.
Long before we ever dreamed of computers, the basic idea of data processing was already taking shape. I mean, get this. In 1801, a loom was using punched cards to remember weaving patterns. That's a form of memory. Then jump ahead to 1880. The US Census is in total crisis mode. It was going to take them almost a decade to count everyone by hand. That's when an inventor named Herman Hollerith, inspired by watching train conductors punch tickets, had this lightning bolt idea. What if we could punch data onto cards and get a machine to do the counting?
The result was, it was staggering. Hollerith's machine took the 1890 census processing time from a projected 8 years down to just 2. It saved the government a fortune, and funny enough, it laid the groundwork for a little company that would eventually become IBM. The punch card was here, and with it, the world had its first universal language for data. But look, physical cards are great and all, but they've got some serious limitations. As we enter the electronic age, we're going to need a whole new way to organize things. This is what leads to the first real database management systems and what we call the age of navigation.
So in the 1960s, an engineer at General Electric named Charles Bachman has this really radical idea. He pictured data records that could actually point to each other, creating this big web of connections. The best way to think about it is like a treasure map. To find the treasure, the data you want, you have to follow a very specific, predefined path. It was super rigid for sure, but man, it was a crucial first step.
And if you want to see just how powerful this was, look no further than the SABRE project. American Airlines and IBM teamed up to build this massive, real-time reservation system. It cost the equivalent of $400 million today, and it instantly dropped booking times from hours to mere seconds. But here's the killer detail, the part that changes everything. They secretly programmed the system to always show American Airlines flights first. This was the first, ice-cold proof that if you control the structure of the data, you control the entire market.
So the navigational model worked, but it was incredibly brittle. You change one tiny thing in the data structure, and the whole system could just shatter. The world was crying out for a revolution, and it came from a lone British mathematician working deep inside the belly of the beast, IBM.
His name was Edgar Codd, and he saw the fundamental problem. Programmers were spending all their time figuring out how to get to the data. Codd's insight was pure genius. He asked, what if, instead of telling the computer the path, you just described what data you wanted? His idea was to store data in simple tables and let the relationships emerge from the data itself. This wasn't just an improvement. It completely changed the game.
But IBM? They hated it. They had poured millions into their existing navigational database, IMS, so they buried Codd's paper. Internal memos just dismissed it as some academic theory, said it was too slow, too resource-intensive, impossible to actually build. Codd basically became a prophet without honor in his own company.
But you can't keep a brilliant idea down. Codd's paper lit a fire in the computer science world. 2 projects immediately started racing to prove him right. Over at UC Berkeley, you had Project Ingress, which became a training ground for the people who would go on to found huge companies. And then, deep inside IBM itself, a secret skunkworks project called System R started building a hardcore industrial version. And it was that little secret team that invented the language we still use to talk to these databases, SQL. So Codd's model was proven to work, but IBM was still dragging its feet. They were terrified of selling it because they thought it would kill their existing products. In that hesitation, it created a massive opening. And a young, ambitious entrepreneur named Larry Ellison was about to drive a truck right through it.
Ellison had read Codd's paper. He had studied the research from System R, and he saw what IBM was completely missing,
a multi-billion-dollar opportunity. His plan was so simple it was audacious. He was going to build his own relational database from scratch, make it speak IBM's own language, SQL, and get it to market before they could.
And that is precisely what happened. I mean, IBM had all the money, all the resources, but they were paralyzed by corporate inertia. Ellison's small team had nothing to lose and was driven by pure startup hunger. In 1979, they did it. They shipped the world's first commercial SQL database, Oracle, a full 2 years before IBM finally got their own product out the door.
By 1986, the war was pretty much over. That was the year SQL was officially adopted as the industry standard. The language that started as a secret research project inside IBM was now the universal way to talk to data, cementing the relational model's complete and total dominance for decades to come.
But just as the relational model stood on top of the world, a new force was gathering on the horizon, something it was completely, totally unprepared for: the messy, chaotic, unstructured, planet-sized data of the World Wide Web.
See, relational databases were built on a promise called ACID, and the key word there is consistency. Think of a bank transaction, right? The money has to be in one account or the other. It can never be in between. It has to be perfectly consistent always. But for web giants like Google and Amazon, that perfect consistency was just too slow. So they proposed a new deal, a new philosophy called BASE. They decided to prioritize speed and massive scale over perfect instant consistency. They accepted the data might be out of sync for a split second. This idea, eventual consistency, was the spark that ignited the whole NoSQL movement.
And that fundamental trade-off, that brings us right up to the modern era. The idea of one single, all-powerful database that can do everything, well, that idea is dead. We have officially entered an age of intense specialization.
Today, a developer is more like a data architect. They're picking the right tool for the specific job. Do you need lightning-fast speed for something like a cache? You're going to use a key-value store like Redis. Are you working with messy, flexible data? That's a job for a document database like MongoDB. Mapping out complex relationships like a social network? That's a perfect fit for a graph database like Neo4j. And the whole new frontier? That's vector databases like Pinecone, which are absolutely essential for the new world of AI.
And the scale of the challenge that these new databases face is it's mind-boggling. By 2025, the amount of data in the world is projected to hit 175 zettabytes. That is 175 times trillion gigabytes. I mean, can you even wrap your head around that number? The job of organizing that sea of information is one of the central challenges of our time.
So, when you boil it all down, it comes to this. From Jacquard's simple punch cards to Edgar Codd's elegant theory to the wild distributed systems we have today, the story of the database has always been about one thing. How do we tame the chaos of information? It is the invisible architecture that makes our modern lives possible, and the quest to build it, to improve it, is far, far from over.